Good morning, everyone. My name is Chip Webb. I work for NUI Systems. We're one of the sponsors of SharkFest this year. It's a pleasure to be here and talk to you and interact with all of the people here with Wireshark. I'm with the NUI Systems, and we make a variety of products. This is one of them. I have an example here. It's a what we call a tool optimizer. It has a number of ports on the front, and we'll talk about exactly what this product does later on in the presentation. The other thing I'd like to do is introduce a few of the other people from the NUI Systems. Jason, Nutt is sitting here in the audience. Raise your hand. Is Hemi here? He's wandering around. We have a couple of other folks wandering around. So if you have any questions at all about our products, feel free to ask any of us at any time. We'll be glad to help you out. The title of my talk is Powering Network Visibility, and it has a couple of subtitles: Testing and Monitoring Network Applications, Optimizing Network Visibility, Tool Utilization, and importantly, Staff Productivity. Start out with an opening thought. The dogmas of the quiet past are inadequate to the stormy present. The occasion is piled high with difficulty, and we must rise to the occasion. As our case is new, so we must think anew and act anew. Abraham Lincoln said that in an address to Congress in 1862. I think it applies equally well to network monitoring today. We'll start out talking a little bit about introductions. Make sure if you're coming in now, you fill out the little forms in the seats next to you, or get one from Jason to register to win an Amazon Kindle. We'll talk a little bit about the network visibility challenge, the tool optimizer approach to solving that, and some of the key features of the dynamic Boolean filtering that has that helps you get your job done on a day-to-day basis. And then we'll do a live demo to see just exactly how easy it is to set up various monitoring configurations that you might have. So first, a little background about NUI Systems. We've been in business now for about 7 years. We have two primary product lines. We sell network emulators and tool optimizers. The network emulators allow you to do pre-deployment testing in the laboratory environment to see if an application will break or perform well when it's deployed. A tool optimizer allows you to monitor those applications in real time on a live network so that you can gather the statistics and the data that you need to manage them. We have deep technical expertise in networking technologies and testing techniques. Our core technologies are packet filtering and modification. One of the hallmarks of our products has been that we always support full line rate at all speeds and feeds with no lost packets. We're headquartered in Austin, Texas. We're on the Inc. 500 and Deloitte & Touche lists of fastest growing private companies. This is a quick list of some of our example customers. I want to start out by making sure everyone knows you can ask questions at any time. Just raise your hand. So I think we all know that network tools need data, and that list of tools seems to be growing every week or every day or maybe even every hour, with new companies starting up with ideas on how to monitor data. Different tools for different users and different job functions. We need to learn how to share access to the data. Some of the people will hook up to newfangled network taps. Other people will hook up using a span port. But either way, if you're using Wireshark for troubleshooting, or you're doing application monitoring, or you're doing security monitoring, compliance audits, administration, or network management, in all of those cases, you need access to data. And the fundamental problem is there's limited access to the data. There are not enough span ports, there are not enough paths to go around many of the tools that you might want to use really need to see a big pipe view of the data. And that can be very difficult because you may have data that goes through different links, and in a switched network, you may need to access multiple links and aggregate them together in order to do a proper analysis. Tools are not cheap. It's expensive to put monitoring and recording tools at all the places you need them. And 10 gig capable tools are still pretty pricey. And staff is not sitting around in their chairs twiddling their thumbs. Most people who are responsible for monitoring networks are busy. I would venture to say that most of them are probably not working a 40-hour week. So if you imagine this is a typical data center where we have an edge router on one side and streams of data go between the edge router and the web servers, and there may be traffic to the app servers and traffic to the database servers. These streams of data that flow through the data center are what you want to monitor. You might want to hook up to one of these streams, and let's take, for example, say you have streams here and streams here, just like this. Imagine this water fountain is your network that you want to monitor. And so you have a crash cart with Wireshark on a laptop, and you go monitor one of those links. So you capture data for a little while. You solve the problem. You're the hero. You're done. The next trouble ticket comes in. You need to get your Wireshark crash cart out again. Go capture some more data. Solve the problem. You're the hero. But pretty quickly you realize that you keep having to drive that crash cart around your data center. You have to attach to the link that you need to see the data. And you might not get the right link the first time. That takes time. So you realize that what you're really seeing is just the tip of the iceberg when you're looking at just one link. So being a smart engineer that you are, you say, aha, what I'll do is I'll aggregate a bunch of links together, and then I can look at the big picture. But you run into a little problem. Those links get kind of fast. You might not be able to keep up monitoring with Wireshark all of those aggregated links. And if you go to 10 gig, it gets to be a real problem. You can wind up just having to sit on it. So point solutions for aggregation and multicasting really aren't enough. RSpan gives you limited ability to filter, multicast. Matrix switches can multicast. Tap aggregators allow you to aggregate, and replicating taps let you do multicasting. None of them do all of what's here, and none of them have an easy-to-use control panel that allows you to set up your filtering and tear it down at a moment's notice. So the Net Tool Optimizer solution allows you to aggregate all of your taps and spans, whichever is appropriate for your application, to a centralized tool farm. You can put in a 5200 series tool optimizer and then connect all your tools to the tool optimizer. So you might have a Wireshark, an IDS appliance, you might have some performance monitoring equipment, a compliance auditor, a voice over IP monitor, and you can connect all of those to the 5200 series. Load balance it by setting up any many-to-one, one-to-one, one-to-many configurations. And then using advanced Boolean filtering that we show here in an easy-to-use GUI, what you can do is optimize the tool utilization. So this is a picture of what I have on the desk down in the front here. If you want, you can come down and take a look at it. This is a chassis that has 20 10 gig ports out the front. That's 200 gigabits. And 4 1 gig ports out the back. There are a series of 10 gig ports as well. These ports can operate at either 1 gig or 10 gig. So if you don't have 20 10 gig ports to monitor today, no problem. You can buy them as just 1 gig today and upgrade them later to 10 gig. It's a modular platform that meets current and future needs. And there are two models. There's one called the 5204, and there's one that's called the 5236. The 5204 has mostly 1 gig capable links and a few 10 gig links. And there's a version called the 5236 that has mostly 10 gig, 1 gig links, and a few 1 gig only links. It's easy to upgrade. Each of these ports are sold in a 1-port increment at either 1 or 10 gigs, so you can buy only as much as you need today, but know that you're ready so that you don't have to do a forklift upgrade in the future. And you can daisy chain multiple chassis together to increase your port count. It's, as you can see, it's a small 1U chassis. It has a redundant, supports a redundant power supply. This is the 5204, the 5236. I'll go through those fairly quickly. You can certainly see that with a GUI like this, it's easy to use. You can meet the deployment challenge for monitoring your network. You can maximize your network visibility by having an any-to-any configuration or an any-to-many or many-to-any, whether you're aggregating or multicasting or filtering. This tool allows you to do that. One thing I should mention, going back here, is that these ports are not dedicated as either inputs or outputs. You select whether you want them to be input or output. So that if you have more spans or taps than you have tools, no problem. You just configure the port as more ports as inputs than outputs. And vice versa. If you have more tools competing for that, you can just configure the ports to do what you want. You can optimize your tool utilization with layer 2, 3, and 4 Boolean filtering using ands and ors. We'll talk a fair amount about the filtering capability because that's one of the key features. It allows you to manage your tools by looking at exactly how much data loads those tools, and you can balance the load using the filters. And because the dynamic filtering automatically handles overlap, and we'll talk about that in a fair amount of detail, it saves a lot of time and productivity when you set up your monitoring scenarios. So the 5200 meets the challenge. It has filtering, aggregation, multicasting, and an easy-to-use GUI. And it has all the key features to help you get your job done quickly, efficiently, and effectively. So we'll talk a little bit about the 3 key features that let you drill down into your data and get exactly what you need and no more, and to share the data. Boolean filtering allows you to create filters with logical expressions such as ands and ors and denies. You can do ranges and disjoint lists. You can set up the filters in minutes, not hours, and you don't have to do any command line coding at all. So it's all done with the graphical interface. The graphical interface was designed in from the beginning. It's not a bolt-on, so that it's fundamental to the product. What makes it easy to use. Dynamic filtering allows you to share data. It handles overlaps between your filters. That way you don't have to. You don't have to keep track of whether one filter or another is conflicting. And it's self-maintaining, which means that on a day-to-day basis, as your monitoring changes, the tool will take care of the overlaps and make sure that your data that's being monitored is not impaired. There's graphical Boolean filtering. This is a quick screenshot of the filter dialog box where you can select pass by criteria, pass all, or drop all. And there are various criteria at layer 2, layer 3, and layer 4. And you can either select packets that match all the criteria or any of them, and they'll be ANDed or ORed together. You can see here an example of a range with the disjoint list. You can aggregate many to any. You can do sharing of spans and taps. Here we show sharing port 4 and port 5 between Application Performance Monitor and an IDS. There's statistics that help you clearly see and optimize your filter configurations. And you can clearly see the topology, and alarms that show up as badges in the GUI allow you to see if you've overloaded a port and diagnose that and remove it. Tool management view is another important feature that allows you to see exactly what's happening to the tool ports. It's basically a drill down on the statistics for any given tool port. It gives you data that allows you to optimize your tools. So that way you can decide if your tools are underutilized or overutilized. Do you need to adjust your filter settings? And gives you the data you need to go to your management and say you need more tools so you can justify buying more tools. So this is a screenshot of the tool management view at the top. There's a total view of the traffic to a specific tool. And then down below, there's a breakdown by data source. So you can see each of the data sources, port 1, port 2, port 3, and so forth, how much traffic is coming in those ports, and how much is being admitted by the filters. You can monitor 10 gig links with 1 gig tools. So if you have a series of 10 gig links that you're monitoring, you can have filters and send them to a 1 gig capable Wireshark. That'll save you an awful lot of money on monitoring 10 gig networks. Here's another picture of a screenshot where we have a 10 gig tool being fed through a filter based on VLAN, the IP4 source address, the protocol, and the layer 4 source port going to a data recorder. So now we'll talk a little bit about advantages of the Boolean filtering available in the 5200 series. We'll start out with a simple example. Let's say you want to monitor all the HTTP and HTTPS traffic on 4 different subnets. So we have 4 subnets and 2 destination ports. The easy way is with Boolean filtering. Just write it down like you would with a capture filter or a display filter in Wireshark. TCP port 80, 443, source network is one of 4, and the destination net is one of those same 4. That's the easy way. Think about it exactly the way the problem is specified. The hard way happens if you need to make out a truth table for a command line interface where you have to specify the filtering rules. So you think about the problem, you make a list of all the cases for your truth table. You have 4 source subnets, 4 destination nets, 2 ports. That's 4 times 4 times 2 is 32 different cases. So now what we do is we go through and enumerate all of those possible cases. Oh, okay, we'll skip that part. So we'll just ask which would you prefer. 32 lines of command line coding like this, or a simple set of criteria like this. I can tell you which one I would prefer. Customers certainly have told us that they agree that this is an easier way to do things. This is a quote from a review in Information Week back in March. And quote, "Using other vendors' filters, we spent the better part of 4 hours and some trial and error to get the map and its filters applied. Anui's dynamic filtering feature, on the other hand, took all of 10 minutes to perform the same task in our tests." I think that's pretty compelling. The Tolly Group has independently tested and certified the Anui to provide full line rate performance for any-to-any aggregation and multicasting at any packet size and at full line rate on all the ports. And so there's 0 packet loss. Now, that's kind of a nice introduction, but it's only part of the story. The previous example we did was 1 monitoring port to 1 tool. As soon as you start having situations where you have a monitoring port going to more than 1 tool, you can come into a situation where you have filter overlap. What is filter overlap? Filter overlap is what happens if you have rules that could more than 1 rule, say 2 rules, that could match a given packet. And it can happen anytime you have an any-to-many configuration. I like to say that filters are guilty until proven innocent, in the sense that you can assume that they overlap unless you have some criteria that's different between them. So, for example, if you had a filter for just a VLAN and another filter for just an IP address, because they have no common criteria that's different, they overlap. Traditional policy files and access control lists don't handle that. And this is a fundamental difference between a piece of networking gear for forwarding packets in a live network and a piece of network gear for monitoring. In a traditional piece of networking gear, it's designed to make one decision on a packet, what to do with it. The packet comes in, it gets forwarded out a given port, or it gets logged, or it gets denied, or it gets dropped. It's not possible in a normal piece of networking gear to make multiple decisions on a packet and filter and forward it to multiple places without setting up either broadcast or multicast rules. So if you have in a traditional piece of network gear set up an access list or a forwarding base, it's going to only fire the first one that it hits. Their priorities. They're listed in order. And so, as I mentioned, a VLAN filter and an IP address could overlap, and whichever one gets executed will be the one that's first in the list. The dynamic filters in the 5200 series automatically handle that case and will forward it to all possible rules that you specify. So let's talk a little bit about one overlap example here. We have a monitoring port going to Wireshark, and Wireshark wants to see VLANs 1 to 3. We have that same port going to a Nixon data recorder looking for VLAN 3 to 6. And we have a Juniper IDS that's looking for all of the TCP traffic coming in on that port. So we have VLAN 1 to 3 going to Wireshark, and this is a bubble in our Venn diagram that we're going to build. And so now we have two bubbles in a Venn diagram, and you can see that there's overlap where we have VLAN 3 is the overlap between these two bubbles. Now we add in the rule for TCP for the Juniper IDS, and we have 3 more overlaps. You can get a sense that the overlaps are important if you want to get the data that you need. Sequential filters don't handle overlap for you automatically. You have to figure that out. The job is up to you to figure out all of these overlap cases and code that into your command line scripts when you set up the tool. So repeating our previous example, but this time explaining what would happen if it was a traditional sequential forwarding. We have VLAN 1 to 3 going to Wireshark, like that, in our bubble. The Nixon data recorder, though, because it's second in the list, it wouldn't get VLAN 3. VLAN 3 is already gone to Wireshark. So while you may have asked it to forward VLAN 3 to 6 to the data recorder, it's only going to see 4, 5, and 6. It won't see 3. And the poor Juniper IDS, because it's at the bottom of the list, it's not going to see any of VLAN 1, 2, 3, 4, 5, or 6. But it will see TCP traffic that's at some other VLAN. I can tell you that if I was responsible for that Juniper IDS, I wouldn't want that situation. Let's go through another example of overlaps where we have tool 1 and tool 2. Tool 1 is looking for VLAN 3, and tool 2 is looking for destination port 80. You go through and you make your list. Okay? Here we have the overlap case. The destination port of 80 and the VLAN of 3 is first. And that's one of the hallmarks of handling overlap manually, is you have to make a list of all the overlaps and order them so that the most overlapped condition is first, and then the priorities go down as a function of less overlapping. If I draw a flow diagram of how that would work, packets would come in and get matched on this filter, which is address 1, and you have this filter, which is address 2, and that filter, which is address 3, and they go to monitor port 1 and 2. And this might be the CLI rules that you get in the end. I don't know about you, but I think that's an awful lot of work to go through just for one overlap. And I would venture to guess that this is kind of a toy example compared to what most people try to set up. In fact, it's pretty easy to have hundreds or even more overlaps. This is our case with just 2 bubbles. If we have 2 tools, but now we have VLAN 1 to 3, and let's say port 1 to 3 is just a contrived example. You get 9 overlaps. You go now VLAN 1 to 4 going to tool port 1, and tool port 2 gets ports 1 to 4 and IP 1 to 4. You get 112 overlaps. And if you expand it much more, you get thousands of overlaps. My brain explodes. So even simple ranges can be very difficult when you need to handle overlaps. And with CLI filtering, it's all up to you to figure that out. You've got to figure out those overlaps and code it up and deal with maintaining it over time. And if you're curious, you're up against this equation. The overlaps for this many criteria with this many values for those criteria is given by this equation. And it should be assigned to you that there are these exclamation points. It's a scary equation to have to deal with manually. So what you really want is a way to automatically handle all those overlaps to optimize your filters. You want it to optimize your visibility and optimize your productivity. There's actually another kind of hidden pain associated with calculating all these overlaps. You might think to yourself, well, I'm smart, I can get it done, and then I won't have to worry about it. The problem is, maintaining them is kind of a daily process, because as you go through managing your trouble tickets and doing your debugging, you have to update your filter rules. And so maintenance of your filter rules can be a huge headache. And it can, if you need to change the forwarding for your tool optimizer on a daily or even hourly basis, that's a real headache. So that means that you have to go through and recalculate all of those potentially thousands of overlap cases, rewrite your CLI scripts, and that's a pain in the butt. The dynamic filtering takes care of all that for you. If you don't take care of it, your visibility and coverage are going to be compromised. And how are they going to be compromised? Well, let's go through an example of what I call the eclipse effect, where we have the example we did before, but with VLAN 1 to 5 now going to Wireshark. So if you decide you don't want to update your rules for overlap, this poor Nixon data recorder now might only get VLAN 6. Juniper IDS gets the same as it got before. It's TCP and it's none of the above. And I think you can see that what's happening is the Nixon data recorder gets eclipsed. The data gets forwarded to the wrong place. So this is our Venn diagram showing that same scenario where we start out with VLAN 1 to 3, and we increase it to VLAN 1 to 5, and it winds up eclipsing the other bubbles in the Venn diagram. So the point here is that the maintenance of those overlaps, it can be a big headache for these monitoring filters. And you can wind up, if you change a filter, eclipsing one tool or another unless you recalculate all those overlaps. The dynamic filtering adjusts the rules automatically so that you can be always sure that the tools get exactly the data that you need. You don't need to continuously rewrite your CLI rules, and it saves hours and hours of time every day. So the optimizer gives you better network visibility, it reduces your tool cost, and it increases staff productivity. It allows you to get your job done more quickly, more easily, and more effectively. So we'll do, I'll ask if there are any questions at this point, and then we can go to a live demo. So this is an example of the graphical interface for the 5236. Again, this is a 5236 chassis here. It has 20 10-gig ports on the front. And in the GUI, we have a series of network ports on the left, filters in the middle, and the tool ports on the right. You can assign names to the ports. So this is named tap 1, tap 2, span 3, span 4. And you can apply any kind of image you'd like to help you remember what that port is. So if you had a port that you wanted to give a custom image to, you could do that. Similarly, on the tool ports, you have the ability to put in custom icons as well. So this is kind of where we're going to end up. The GUI has tabs on the left-hand side that allow you to see a diagram view, a filters view, a ports view, users and system. Quickly, the filters table shows you a table of all the filters that you've got. The port view gives you a list of all the ports, users, etc. So what I'll do is I will import basically a blank configuration, and we'll work up to something like that to show you how easy it is to set that up. So what I'm going to do is I'm importing a blank configuration. And there we go, it's imported. And I will log in again. I imported the wrong one. The factory reset. We'll import the right one. There we go. So here we go. None of the ports are configured at this point, and I'll start out by configuring some taps. So you just double click on that, and I'll say tap number 1, and I will enable it, and I will set it for 1 gig SFP, and I will give it tap icon. Okay, and we'll set up this as tap number 2. It will also be 1 gig enabled with the tap icon. Done. So there we go, we've set up 2 tap ports. Now we can set up some monitoring ports. Let's say this is Wireshark number 1. It's a tool port, it's enabled, and let's browse for a Wireshark image to use. There we go. So I'm going to take the wrong data rate. 1 gig. Okay. And now we can draw a line like that. We'll ask us if we want to give it a name. We can give it a name. It's filtered, and we'll set it up to pass everything to start with. And then we can connect up the other tap. Let's add a span port. The network, 1 gig, it's enabled. And image, okay. Do the same thing for the next port. It's 1 gig, it's enabled, and then we connect it all up like this. And there we go. We've just aggregated 4 monitoring points. We have tap 1, tap 2, span 4, and span 5 going through chips filter to Wireshark number 1. And this is a pass-all filter. You can see now that we've got a little badge that's yellow. That little yellow badge is telling us that there's something happening that's not so good. And what's happening is we have 4 1 gig links going to this 1 gig output port, and it's overloaded, so it's dropping some packets. If you hover over the badge, you can see that the alarm is that there are dropped packets. If I right-click, I can look at statistics, and you can see in the statistics that it has dropped 2 million, almost 3 million packets. It's not happening all the time because the inputs are bursty. And so what we need to do is to do some filtering. So we'll open up our filter again, and we'll say pass by criteria, and we'll set up an IP destination address. Let's set that up to be 192.168.10. Let's say 10, 20, 30, and 100 through 200. And let's set up a TCP destination port of 80, say. And you can type the number if you know it, and it'll automatically come up with the name of the protocol as a reminder for you. You can say OK. So now, if I reset my statistics on that port, you'll see that the alarm goes away. So that shows how easy it is to set up aggregation with filtering and optimize the use of this Wireshark analyzer that's connected to those 4 network ports. So now let's say we have another Wireshark and we want to share access to that. So we'll open up port 6, say that's Wireshark number 2. It's 1 gig, it's enabled, and we'll browse for our Wireshark image. Say OK. Oops, it's full port. That's exactly how easy it is to switch a port from input to output. There we go. Let's draw that. Connect it up. Now the criteria is to pass all. OK. And then let's take both of the span ports and hook them up to the second instance of Wireshark. So now this shows you just how easy it is to set up sharing for these span ports. So you can take the traffic that you're interested in from the span ports and send it to this Wireshark, and have different traffic that you're interested in for this Wireshark instance. Let's say we have a 10 gig network port hooked up to a backbone. So it's 10 gig full duplex, it's enabled, it's a network port, and we use a different icon for that. And let's say we have a Nixon data recorder, and it's a 1 gig SFP, it's a tool, and it's enabled. And let's browse for Nixon icon, say. OK. And then we take this 10 gig, hook it right up, pass all. Guess what happens? We get dropped packets. So we'll set up some filters. This time we'll pick VLAN 100, 102, 200, and 202. And let's pick layer 4 port. Destination is 25, say. OK. Reset your statistics. That. And now you're monitoring all the SMTP traffic on several VLANs from a 10 gig backbone using a Nixon data recorder. Piece of cake. Are there any questions so far? Yes?
When you're configuring the IPv4 there, I saw it said source destination. If you set up as either, is that going to get traffic in both directions?
Not today. So to do that, you would set up two filters in parallel and select one filter for source and the other for destination.
And then another question is, if I wanted to put a filter on temporarily, is there a way to save that filter out and maybe apply it again later?
Absolutely. What you can do is you can take this, let's say I take this filter, Control-C, Control-V, copy, and there you go. That's a copy of the filter. You can create a copy of the filter and keep it at the bottom of the diagram if you'd like. There, in an upcoming release, we'll have a more formal library for filters. So ask me the question again in 3 months, and we'll have a nifty library capability for you as well. So now let's look at the traffic going to this Wireshark using the tool management view. Any tool port, you can right-click on it and go down to the tool management view. It brings up a very nice panel that helps you see the traffic that's going to that tool port. So at the top, we can see that the transmit utilization on that is about 11% overall, and we have 4 sources for that. Unfortunately, the screen is a little bit small. But you can see that there's each of the ports, network ports, has traffic coming in, and so it's showing it's a little bursty. You can see that it was 10%, now it's 40%, now it's 37%. This one's 5%, now it's 41% down here. And the amount of traffic that is matched is shown just below that, the amount of traffic that gets passed. And that gets all added up. So by looking at those numbers, you can see if you have dropped packets, you can say exactly where that congestion is coming from. And it allows you, if you can, to move some of that traffic around to different tools, load balance your tools so that everything can be done efficiently. You can also see current and average statistics and looking at your packets or bits and bytes. And you can export it to a CSV if you wanted to, for example, include that in a report to management.
So that's like a snapshot of whatever you...
That's right. You can have a snapshot of whatever you have. Another thing you can do that's kind of handy is, let's say one of these ports is important. You can say, do not touch call chip extension 102. Update that. And now anybody that logs into the box will see this. One of the things I didn't mention is that this is a fully multi-user graphical interface. So any number of users can log in. They will all see this view. And as you change your view, their view will automatically be updated. They don't have to do any refreshing or anything like that. And you can have dozens of users pointing at and logging into it so that you don't have to worry about only one person can log in. Let's say the graph gets a little complicated. You want to narrow your view to only look at the stuff you're interested in. Maybe you're only interested in this Wireshark 1. You can say focus on the selected object. And what that does is it puts you in what we call focus view, and that's indicated to you by the light green highlighting on the things that you're focusing on. And you can see what's connected to it. So it kind of declutters the diagram for you in case the diagram gets a little complicated. There's a series of function buttons. You may not all be able to see them, that you can click on. So for example, what happens when I highlight, put my mouse over one of the links, it highlights the path associated with that all the way one end to the other. So those are ways that help you see exactly how the diagram is configured and understand what your setup is. I'll go back to see the whole diagram. And let's say this copy of the filter that I saved off, let's say I want to hook it up. One of the things you can do is you can change the connections by adding a port. Let's say I want to add tap 1, and I want to add tool port going to Wireshark 2. Let's say OK. So you don't have to use the GUI if you don't want to. Here is that saved, the copy of the filter that was saved. So now it's going that way. And it's automatically arranged the diagram for you so that it keeps it as neat as it can. I talked a little bit about copying and pasting. And there are a series of interesting tabular views that you can set up. So for example, you can see all of the filters under the Filters tab. You can either look at the settings of those filters or the statistics associated with those filters. You can see what's the percentage matching, how many packets are inspected, how many packets match, how many packets per second are matched, that kind of thing. Similarly with ports. For example, you could sort the ports to look at all of the tool ports and then all the network ports. And you can see what's the configuration, whether the link is up or down. And you can also look at statistics. As I mentioned, it's a multi-user system. Right now we have 2 users configured. One is the administrator and one is me. You can have as many as you like.
Can you set up role-based to see what they have in tenancy, how they access it? Was there any role-based?
Not today.
Okay.
In the next release, we'll have groups and role-based administration as well. Yes?
Does multi-users imply auditing?
Yes. There is a log file that keeps track of who's done what. In the system settings page, you can set up a variety of system settings such as the login timeout, the server log level, the IP address configuration, whether you want the fans to run full tilt or automatically, SNMP configuration, whether you want it to be local authentication or TACACS, DNS configuration, and you can manage your licenses and your software installs very easily using this page. So that's kind of it. Are there any questions? Well, thank you very much, everybody.